Hi, this is the second part of your Chapter 3, Lesson 2. Um, we're talking today about solving systems of inequalities. You just learned how to solve systems by graphing, and the first thing that we talked about was how to determine if it was a solution. Well, in this case, you need to be really careful because there can be many solutions to inequalities. This is when we say, okay, x is less than 3. Well, there are many, many numbers, infinitely many numbers, that are less than 3 that you have to include in your solutions. So the same thing is true here. I'm still going to, when I'm trying to determine if this ordered pair is a solution, I'm still going to plug in the x and y and see if my ending result is true. So plug in y, which would be negative 3 in this case, is less than or equal to negative 3 times the x value, which is negative 1, plus 1. So negative 3 is less than or equal to, this becomes positive 3 plus 1. Well, 3 plus 1 is 4. So negative 3 is less than or equal to 4. Then you want to think to yourself, is negative 3 less than or equal to 4? The answer is yes, it's true. This is good. Negative 3 is less than or equal to 4. Okay, so the solution works for equation or inequality number 1. Let's check out number 2. Negative 3 is less than 2 times negative 1 plus 2. So negative 3 is less than negative 2 plus 2. Negative 3 is less than 0. Is negative 3 less than 0? Yes. So therefore, they both work. So is this a solution to the equation or inequalities to the system? Yes. Okay, let's try the second one. 5 is less than negative 2 times negative 1 minus 1. 5 is less than 2 minus 1. 5 is less than 1. That's not true. 5 is not less than 1. So we can just stop right there because in order for it to be a solution, it would have to work for both. And since it didn't even work for this one, we can go ahead and say no. All right. So you need to remember when you're graphing inequalities how to actually graph and make sure you shade and you use the correct line. Is it solid or are you dashing the line? So you need to be really careful and make sure that you do all of that. All right, the first one. The first one says y is less than or equal to 3. Well, there's nothing to plug in for x. So I know no matter what I use for x, 0, 1, 2, 3, it doesn't matter. The y value will always give me 3. So I go up to 3 and I'm going to put, okay, at 0 I would be at 3, at 1 I would be at 3, at 2 I would be at 3, at negative 4 I would be at 3. No matter what I choose, 3 is always the result here. Since we are less than or equal to, I get to draw a solid line. The equal to makes it solid. And when it says less than 3, well, a y of 3, the values that are less than will be below or underneath. It's everything that falls beneath that line. Okay, for the second equation, graph it just like slope-intercept form. It is in slope-intercept form, so graph it with your y-intercept and your slope. So I'm going to go to 5. That's my y-intercept. And this is understood to be negative 1, so it's a negative slope. We go down 1 over 1, down 1 over 1, down 1 over 1. I don't really care about the intersection point. That's not really telling me much about this. Be careful when you draw this line because it says it's greater than, but there is no equal to. So we're going to draw a dotted line or dashed. And then we need to make sure that we shade correctly. So it says y is greater than. If you want to do a test point, you need to be careful because you don't care about any other thing but this line right now. So everything else that you've already drawn needs to be put in the back of your brain. This line here, I need to be greater than the line. So if I use the test point 0, 0, if I put in 0 here and 0 here, I would get y is greater than 5. I'm sorry, 0 is greater than 5. 0 is not greater than 5. So if I'm looking at the line, there are two sides, the top side, this side here, and then the below side, what I like to call the below side. The 0, 0 that I just tested is on the below side, and it did not work. So I need to shade on the other side where it would work. So up here is where all the shading is. Now it's really good if you use two different colors because then you can really see the overlapping. But notice this triangular area here has been colored twice. This region, you want to darken it up because it was colored twice. This is where your solutions to the system exist. There's not just one answer here. There are many, many answers, and if my graph were bigger, you would be able to extend the line, the horizontal line, and extend the one that goes through it out further so you could see a bigger region. But your solution, you don't just give me an answer. Don't tell me that it's this point right here. It is all of these answers because we're working with inequalities. Okay, so two solutions that I could give to answer, like if you wanted to show me that you knew where the solutions were, you could say we could go 4, 2. That's in the shaded region. There are many results or many solutions that you could give me here. You could go all the way 10, 0. That's in there. Anything that's in this colored area, if I asked you to give me a solution, you could say any point that's in there. Okay, let's try the next one. Put it in slope-intercept form first. So I'm going to have 2y equals, move the -3 to the other side, 3x plus 3. And I'm sorry, I shouldn't have said equals. Should be greater than or equal to. Divide everything by 2. Let's go ahead and change this to a 4. The value here to a 4 so we make it nice. Okay, and so we'll have y is greater than or equal to 3 over 2x, and then this gets divided here and it's plus 2. So don't forget, both terms get divided by 2. Alright, let's graph it. So we go up 2, that's our y-intercept. Then we do 3 over 2, so up 3, 1, 2, 3 over 2, 1, 2. Up 3 over 2. Or we could go down 3, backwards 2. Down 3, backwards 2. Your symbol here, your inequality symbol, says that you can have a solid line. And when we shade, y is greater than the line. Another way, if you want to visualize this, instead of always plugging in a test point, you could say, okay, if I were to take, I'm using my pencil as the line, if I were to take this line and make it horizontal, I would just go like this, right? Okay, if it were sitting horizontally like this, and I said greater than, you would say shade up here. Greater than means more, so you would say shade above. If you think of that shading being on top here, my hand is now the shading for the pencil. If you were to turn it and put it back in its place, look at where the shading goes. The shading is up here. So greater than would be up here. Now, if you still want to do a test point, you could still choose 0, 0 and plug it in. This would be 0. This would cancel out and be 0. So you'd have 0 is greater than or equal to 2. 0 is not greater than or equal to 2. So notice we did not shade 0, 0. Let's do the second one. Up 3. And we're going to go 4, 1. 1, 2, 3, 4 over 1. I can't go more that way, so I'm going to go down. 1, 2, 3, 4 backwards 1. 1, 2, 3, 4 backwards 1. And in this case, we need a dashed line because of the symbol. And for this line here, we say less than. So if I were to take it to horizontal, I would shade below, and then if I put it back, all of this section over here. Also, a test point, if I plugged in 0, 0, remember we're looking at this line. If you plug in 0, 0, you'd get 0 is less than 0 plus 3. So 0 is less than 3, that is 0 is less than 3, that is true. So you want to shade where 0 is, but all the way on the line. Remember, two sides of the line. This side, which does not have the shading because we don't want to shade that side, and then this side. So you need to shade all along this line beneath it. Be careful because there's two lines going on, so you need to make sure that you shade the correct one. Now, the overlap is in this area right here. That's where we need to darken it up to show whoever's grading your papers that you know where you're talking about. Okay, so if we find two solutions, we could go over 2 and up. Don't pick one on the line unless it's a solid line, but that's still not really a good choice. So pick, let's see, 2, and then if we go up 2, up 5, so 2, 5 is a good one. You could go 3, 9, that's fine. Anything in that region is okay. We're not going to do the back problem. We'll talk about this in another video. And so if you have any questions, let me know. And we'll see you soon.